In this video, we're going to introduce the frequentist risk, the Bayesian expected loss, and the Bayes risk. And I'm really excited about this video because for a long time, understanding the relationships between all these different concepts was ultra confusing, but it's really not that complicated. What makes it confusing is just mainly a bunch of bad notation and sort of disorganized presentation of these concepts. But we're going to see a very nice way to sort of understand the relationships. Okay, so let's get started. So as usual, we're going to have some data, and our data will be random variables x1 through xn. And let's assume that all of the data is a random variable with some probability distribution p sub theta. So it's p. So theta is some parameter that it parameterizes the set of distributions for d. And then we'll assume for now, for the sort of general perspective, let's assume that theta is distributed. It's a random variable with some distribution pi. We'll see in a second how this does not play a role in the frequentist concepts. Oh, and one other thing, we need to have our, let's put it over here, our estimator, theta hat, a function of the data, the usual thing, and we'll call that function f. Sometimes people use delta here instead of f, so you could replace f by delta throughout all this, and everything would work just the same. But I wanted to emphasize that it is a function. Okay, so everything begins with the loss. We have some loss function. Let's put loss equals L of theta and theta hat. And actually, let me put theta hat's f of d. So to emphasize the dependence on d, let me put f of d here. Now, when we're doing decision theory, we want to minimize our loss. But this is not really a completely well-defined problem because these are random variables. Theta is a random variable and d is a random variable. So what does it mean to minimize the loss? Well, we have to do something else. We have to sort of take an expected value or something. So there's sort of two options here. The first option is we have two random things. Let me make those a little shorter. So there's two possible paths. The first path, if we go left, we could average over theta. So this is averaging over theta. We would get the expected value of the same thing given, not theta, given the data. So we're averaging over, this is the expectation over theta given the data. The other option would be to average over the data given theta. So we could, if we went this way, we would get the expected value of the loss given theta. So this way we're averaging over theta, and this way we're averaging over the data. This side is written. This is a function of. So this is a function of the prior on theta, right? We're averaging over theta with respect to this prior distribution. So this depends on that prior distribution and the data. We're conditioning on the data, and this is called the Bayesian. Let me put this in blue. Blue for Bayes. This is called the Bayesian expected loss. The Bayesian expected loss is this thing right here. On the other side, this is a function. We'll call it r. These are standard notations. R, and it's a function of theta, right? We're conditioning on theta, and it's also a function of f. Oh, sorry, on this side I should have put, that would be okay, but we want to make the dependence on f explicit also. So this is, sorry, I defined this wrong. The Bayesian expected loss is rho of pi and f of d. This only depends on the data through f of d, so we can write it this way. So it depends on the value that you choose. And on the right, so this part, let me put this in red. This is called the risk, or the frequentist risk. Sometimes they just call it the risk. And then we can average over, so we averaged over 1 on one side, 1 on the other, and we can always come back to the middle, average over the other thing that wasn't averaged over, and we get just the expected value of over both of those things. So it's just the expected value of the loss, not conditioned on either one. So if you took the expected value of this side, you would get this. If you took the expected value of this side, you would get this also. And this is called, well, it's written, the notation is little r, and it depends on, what does it depend on? Well, we averaged over pi. Well, we averaged over theta with respect to pi. So it depends on our prior pi. And it also depends on this function f. Here, we could just write f of d because we were just considering a particular value of d. But here we're averaging over d, so it really depends on the whole function f. We can't just put f of d here. And this is called, let me put that in purple, this is called the Bayes risk. Bayes risk. And so frequentist, calling this the frequentist risk is sometimes, I guess probably people do that in order to distinguish it from the Bayes risk. And now, so to see, so a way to remember all these different formulas and what's going on here is the following. On this side, so let me draw a big circle here, or a big oval. Oh, let's try to not. This blue side here, let's call this is Bayes world, or Bayes land. Over here, we're in Bayesian world because we've averaged over theta. Averaged over theta. And in red, let's put another corresponding circle or oval over here. This, let's call risk world. Risk world. R for risk. So B for Bayes and R for risk. I've chosen my colors ahead of time. And in risk world, we're averaging over the data. So we start out here. So wherever we are, so we start out here and we have a loss function, but this is random. And if we go in this direction, if we go towards the lower left, then we're entering Bayes world, and we pick up a Bayes in the term, so to keep all the terms straight. So you start out with a loss, and when you enter Bayes world, you get Bayesian expected loss. And if you instead went to frequentist world, or if you went to risk world, you would get the risk. So you pick up a risk. Now, if you were over here in Bayesian world, if you had Bayesian expected loss and you entered risk world, then you would keep your Bayes. You're still in Bayes world, but you pick up a risk. So maybe I should put risk in red and Bayes in blue. So when you're in Bayes world, you have a Bayes in the name, and when you're in risk world, you have a risk in the name. So that's just a little sort of picture to help you keep the keep all the terminology straight and the relationships between them, right? Because when we're in risk world, we've averaged over the data. Whenever we're over here, we've averaged over the data, and whenever we're in Bayes world, whenever we're in the blue part, we've averaged over theta. So this is very simple and totally obvious probably to you the way I'm explaining. I hope it's totally obvious, because it's not totally obvious when you're learning this stuff, and all the notation in these different cases is different and the terminology is different. So I hope this is blindingly obvious to you. Okay, so now back to the original question, which is, what do we do, right? What procedure should we choose? So let's talk about how this tells us what do we do in these different cases. The Bayesian set. Well, let me back up. So before I get to that, let me say one more thing about this. So what justifies these different perspectives, or what are the arguments? Well, the Bayesian perspective is, the Bayesian says, we should use this, right? Because we know the data. I mean, typically we get some data and we want to minimize the risk of the action that we're going to take. So the Bayesian perspective is, we know D. Let me put that in here. We know the data. So why would we average over the data? That seems like a silly thing to do, right? But the frequentist says, or the person in risk world, usually they're called frequentists. The frequentist says, but we don't know pi. We don't know the true prior. Or even if there is such a thing. I mean, the frequentists often would say theta is a true value. It's not a random thing. It's a true thing in the world. Oftentimes, you think about the mean of some, like the speed of light or something, and you wanted to measure the speed of light, or the speed of sound. You want to measure the speed of sound. It's a true fixed quantity. It's not a random thing. So in some sense, to the frequentists, they say, well, not only in general, we don't even know pi, but it might not even make sense to think of theta as random. And in any case, we don't know pi, so you have no justification in doing this and using that pi, that prior, to make your decisions. So there are good reasons for both camps. I'm not going to take sides in the debate here. I'll just say that there are good reasons in both sides for what they do, and it really depends on the situation that you're in as to which type of procedure makes more sense. Okay, so I really hope that this made these concepts and these definitions and the relationships between them perfectly obvious, and hopefully now that you've seen this, it will be clear in your mind how all these things are related.